Okay, welcome back. First, quickly, I want to make sure you understand this kind of symbology that if you got the P out front, that means the probability of whatever's in here. It could be words or it could be like a number. Probability of 2, maybe from rolling a dice, the chance of a 2 coming up is 1 out of 6 since there's only 1, 2, and there's 6 sides. So you can write that as 1/6. Or if you do 1 divided by 6, it's 0.16666 repeating. Or if you change it to a percentage, it's 16.7. But very often you will see written, the probability of something is equal to, and you have to figure that out, or maybe you have to figure out, given that probability, what's the event that goes in there. So here the event is 2. And once again, another one of our vocabulary words is sample space, which would be, in this case, the sample space would be each of the numbers. 1, 2, 3, 4, 5, 6 are in our sample space. I told people who showed up to class I wanted to show this really kind of fun experiment that was in the book, which I'll point out again in a minute. But the idea is you get a whole bunch of pieces of paper, and maybe you write names on them, or just letters. I wrote letters A, B, C, and D on here a whole bunch of times. And I've got like 20 of them, and I'm going to put them in a bag. And the idea is I got my mystery bag. I can't see it. It's got a question mark on it. My mystery bag here. I shake it up, and I pull one out, and I find out that it's a C. So I write down, okay, I got a C and I got a 1. I happen to know there's A's and B's and D's in the bag as well. And so I put it back in the bag, so this is with replacement, is what this is called. And I shake them back up, and then I pull another one out. And I pull another one out, and the next one, oh, it's also a C. So I mark, okay, C there. And then put it back in the bag, and I shake them back up, and I pull one out. And the next one I pull out is an A. So I do that, and probably I need to do that at least 10 times, but depending on the how many things I'm looking for, I did it to 10 and then to 20, and here's what's interesting. Eventually, you should start being able to figure out, well, how many A's, how many B's, how many C's, and how many D's do I have in the bag? But it doesn't always work out that way because we have the theoretical probability, which is based on the number of each that's in the bag, and then we have the experimental probability. And so this is what I got after I did this. I actually, after 10 tries, I had 1 A, 4 B's, 5 C's, and 0 D's. And then after 20, I had 2 A's, 5 B's, 12 C's, and 1 D. So this is kind of the distribution I would expect in the bag. Is a lot of C's, quite a few B's, not so many 2's and A's, and hardly any D's. In reality, the thing I had the most of was A's. And the second most thing was C's, and they were about the same. I did have quite a few B's, but less than A's and C's, and I had very few D's, so that came out about right. But this was way higher than I would have expected, and this was way lower. So that'll happen. If you do enough samples, eventually this will become whatever the breakout is in there. But just based on looking at these, you can never be guaranteed that your sample exactly mimics what's called your population. The population being everything that's in the bag, and your sample being what you pull out of the bag. I want to remind you again kind of how our normal thing is going here. I am going to post a bunch of problems, which I'm going to let you look at your own. I've got some other ones that I'm going to do, and people who've already been to class have already tried these, so you could look at these and then come back with questions if you're not sure. I've got some other problems that I'm going to show you. And then if some of these don't quite make sense, the idea is to go back and maybe go through the reading, especially the summary. You can usually skip over the stuff at the top because it's kind of the longer version of the lesson, but definitely probably go down and read the summary, and I'll let you go back and read that on your own. You know where to find it. But once again, they said, the probability of winning a ticket is 0.015 or 5 out of 327, or if we were going to convert this to a decimal, it would, they did it down there, sorry, to a percentage, it's 1.5%. So once again, that's how you write that. It's a little hard to see. I'm going to zoom in a little bit. Okay, so finally, a few questions. So I've got some questions queued up for you, which I'm going to put up on the screen. The first one, 10 coins placed in a sack. 3 of them are pennies, 2 are nickels, 4 are dimes, 1 is a quarter. If 1 is chosen at random, what's the probability that you pick a nickel? This assumes you are picking them at random and you're not feeling like how big they are or anything like that. So take a second to answer that. All right, select all the words for which both of these probabilities are true. Probability of picking an E is 20%, and the probability of picking a consonant is 3/5. And your choices are cheat, meets, greets, adhesives, aggression, and advertises. Now, one of the things you might need to do to make this easier is to realize that 20% is 2 or 20 out of 100, or 2 out of 10, or 1 out of 5. That makes it a little easier if you realize that P of E is 2 out of 10, or 1 out of 5. For the spinner below, which of the following sectors have the probability of 1/10? And this, once again, this would have to be, you don't know for sure, but you can probably guess which one is 1/10. And the other one is, this is supposed to be round. It doesn't quite look round on my phone here. I think it's because I'm at an angle. What about 1/4? What would be a probability for 1/4? Same question, same spinners. For the spinner above, the probability of green is 1 out of 8. So I'm telling you that is 1/8 of the pie. Oops. And the spinner spun 200 times. Estimate the number of times it would be expected to land on the green section. And finally, I've got a challenge down there for you. What is the probability of green or blue? Sorry, probability of blue or green. Shouldn't matter, blue or green. And then what's the probability of blue and green? All right, this turned out to be a relatively short one. I'll see you soon. Bye.